Hey guys, back with another equipment repair video. For today, it's the OG, the trusted Zoom H4N. Released around 2009. We got ours around 2012. It is, for me at least, the device that started my career in location sound and in sound in general. Why are we fixing it? Well, I think it's still a capable recorder. It records in 96 kilohertz 24-bit XY stereo recording. I think it's still good for ambiances and sound effects. Well, the preamps, of course, are a different story, especially if you've experienced cleaner preamps. But for me, it still works, right? The only problem is the headphone socket. And if you use it like we do, and as you can see in the video, we use it a lot in the field. We liked it so much, and it's what fit our budget. Back in the day, we even bought two, but the problem is the headphone socket, right? Again, on the field, off the field, day in, day out, you plug your headphones there all day, every day, and that small 1/4 inch jack is going to give eventually. And at least that's what we experienced. We experienced it on the first recorder, which you can see has seen a lot of field use. We've experienced it on this recorder, which was the second recorder that we purchased. After that, we simply moved away from Zoom. We moved on to Tascam. That's a story for a different day. So I found the time to research, and finally, we now have a headphone socket parts number. And it's readily available, and I thought to share what I've learned. So I'm going to talk about the headphone socket part first, but if you guys are not interested in that, you guys can go straight to the repair build, and I'll see you on the inside. I'll go ahead and go straight to the key takeaway, and you guys can just go straight to the disassembly and assembly video. But I just wanted to share my experience on these sockets. In my experience, at the time of my repair and research, the H4N uses the PJ3043, the normally open headphone socket. And with that, thank you very much for dropping by. You guys can go straight to the disassembly and assembly section of this video and see how you can desolder and solder on this component onto the PCB. But if you're still here, I basically made a mistake in my first purchase. I thought all these headphone sockets were the same, all right? And some of the documentation is confusing, and even the documentation of the suppliers are not consistent, okay? The first batch that I bought was this. It's a pink 6-pin headphone socket. All right, looks very similar. And if we look at it from the top, let me try and explain this. So these are just dimensions for the said part. And that's the top view of the PCB layout, right? So if you're looking at the PCB from the top, you'll know that pin 4 is on this side, the topmost, pin 4. Pin 3 is the one in the middle, pin 6, followed by pin 2, and then pin 5 is the one here on the outermost part of the headphone socket. Pin 7 is that pin over there in the middle, all right? But the easier way to show you this is to flip the component around. So just take note that we are looking at a mirror image, where this is pin 5, the one on top. This is pin 2, followed by pin 6, pin 3, pin 4. Pin 7 is still that bit over there. Okay? We'll skip this PCB top view, and I want you guys to turn your attention to the behavior of these circuit diagrams here at the bottom. Particularly this PJ3043 and PJ3053, right? Now this pink unit is actually the PJ3053, which is a normally closed headphone socket, 6-pin headphone socket. So hopefully you guys hear this. All right, so that's my tester on the continuity test. What this diagram tells us, and it's quite easy to decipher, you've got pin 7, 5, 2, 6, 3, 4 from the top down. Okay? So if you look at the component, we have pin 7 in the middle, 5, 2, 6, 3, and then 4, right? Basically, when you insert your TRS jack over here, or your 3.5 millimeter headphone plug, it'll insert here. Your tip will make contact on this lever. Your ring will make contact on this lever. And your sleeve will make contact here on pin 7. Right? So that's where your TRS jack will make contact, all right, as you insert the plug. Now, this black band over here, my understanding is it's probably a plastic, some form of plastic, holding pin 6 and pin 4 together, right? It doesn't bridge the connection, it's just holding pin 6 and pin 4 together, all right? In such a way, when you have your jack come in and your ring makes contact with this lever, it'll swing this U section down, therefore breaking the connection of pin 3 and pin 4. All right? And simultaneously, the tip, as it makes contact here, it'll push this lever up, breaking the connection of pin 5 and pin 2. Right? So, this headphone socket is a normally closed socket. Ergo, if you look at the pink headphone socket here, that means pin 5, which is this one on top, and pin 2 is shorted, it's closed. Right? And pin 3 and pin 4 is also closed. So pin 3 is this, pin 4 is here. Right? That's what that means. It's when there's nothing inserted, when your headphone jack is not inserted here, you have a closed circuit on both ends, right? Now, if we get a regular TRS to TRS 3.5 millimeter patch cable, and insert it on one end. Okay. On the other end, I'm going to grab on to the, changing to the probe with the helping hands. So right now I'm on the tip. So that means the tip should go to pin 5. And true enough, it goes to pin 5. It will not And the connection to pin 2 will be disconnected, right? Then if we go to the sleeve, if we go and hold on to the sleeve, right? The sleeve will now go to pin 6. And pin 6 is this one in the middle. Right? But everywhere else, it's disconnected. The ring will not go to pin 4, and it will not go to pin 3, as you can see from the continuity test. And just to complete our continuity test, the sleeve, this bit here, will connect to pin 7, which is there in the middle. So this pink headphone socket, the PJ3053, is a normally closed 6-pin headphone socket. All right? But that's the wrong part. Okay? That's the wrong part. This is the exact headphone socket that I pulled out from the original H4N, and we'll see that this is actually PJ3043, which is a normally open headphone socket, right? So based on what we know from the previous schematic, we can see here that pin 5 and 2 is connected when there's no headphone jack. And we know that pin 3 and pin 4 is disconnected when there's no headphone jack. Additionally, pin 6 and pin 3 are connected via this bridge over here, right? So pin 6 and pin 3 is connected via this bridge so that when your 3.5mm jack comes in, tip will make contact with this lever. It'll push it up, therefore disconnecting pins 5 and 2. Ring will make connection to this lever, pushing it down, making pins 3 and 4 connected, and then your sleeve will make connection to pin 7. So that's why this headphone socket, which I pulled out from the original H4N, is a normally open 6-pin headphone socket, right? Because pins 3 and 4 is normally open when there is no headphone jack connected, right? So let's try that. So we know that when there is no headphone jack connected, we know that pin 5 and 2 should be shorted, right? And then pin 6, 3, and 4, none of them should be shorted. There should be no continuity, right? So 6 and 3 is not connected. 3 and 4, nothing there, okay? 6 and 4, there's also nothing there, right? Pin 7 will always be floating because it connects the shielding, right, on your sleeve. So let's do the same test as a while ago. We're going to insert the jack here. On the other end, let's go and hold on to the tip first. The tip, as it inserts into the socket, is going to lift and disconnect pins 2 and 5. So the tip should be connected to pin 5. Right? But it will not be connected to pin 2. Right? Again, it's connected to pin 5. Tip to pin 5. Right? Moving on, let's latch on to the ring now. So now we know that the ring will make contact with pin 6, right? So again, the ring will make contact with pin 6, but it will not make contact with pins 3 and pin 4. Again, the ring will just make contact with pin 6. Right? But based on this schematic, once we insert your TRS plug, we know that pin 3 and pin 4 will indeed be connected. There we go. So that means we're not getting any continuity, right? It's messing about. There we go. Now we've got continuity. There, okay. Probably that's why this was problematic, okay? We've got a loose connection now between pins 3 and pins 4. There. It's working well now. Maybe I just didn't probe it correctly. Let me try a different one. This is a brand new one. Again, this one is the socket I desoldered from the PCB. And then we'll be using, this is a brand new one from the stock that I bought. Let's see if it'll work, if it'll behave similarly. There we go. So pins 3 and 4, when you have a jack inserted, should be connected. And let's just verify. We're going to connect to the tip again. Tip should be connected to pin 5. There we go. Let's move on to the sleeve, right? Sleeve should be connected to pin 6, right? And yeah, just to complete the continuity test, the ring, I made a mistake. The ring should be connected to pin 6, which indeed it was, and the sleeve should be connected to pin 7 and nowhere else, right? So that means we don't have a short happening, okay? Right, so then again, just to reiterate, that's what I learned as I went through repairing the headphone socket for the original H4N. Again, what you need is a normally open 6-pin headphone socket. I can't vouch for the parts number because even I had a hard time looking for the parts number, and sometimes the documentation is not always clear. But hopefully, given this diagram and what you know now, you can now make a more informed decision if you're going to be purchasing a particular part or the particular part for your repair for your H4N. Again, I'm not actually sure if this is the same headphone socket for all H-series recorders. All I know is this is what worked for my original H4N. So with that, let's proceed to the disassembly, repair, and reassembly of the unit. So there are a couple of hidden screws behind the rubber bumper on the top part. 4 screws around the back and 1 long screw in the middle. You should preferably use a flat plastic prying tool, like a guitar pick. But you can also use a flathead screwdriver to pry open the back plate. Just be careful because you might scratch your unit. be careful when you lift up the back plate. Disconnect the battery connector first and the external speaker cable. In my case, I had mine disconnected already. But yeah, these are called cable to board PCB connectors. They only insert one way, so don't worry too much about sliding them back into place. You do have to remember though where each cable came from. So best to take a photo to help you out on that. So once you're done with the back plate, go ahead and unscrew and remove the XY mic capsule back housing. Alright, so at this point, we can already see the internals of the unit. So the H4N has 3 PCB layers. PCB stands for printed circuit boards. So to remove the top first one, you're going to have to disconnect the power cables, or at least these 2 power cables. The first power cable goes down to the XLR assembly, most probably to provide 48 phantom power. And you're going to have to remove the power cable going to the XY stereo mic assembly, most probably for plug-in power for your lavalier mics or to provide power to the XY condenser microphones. At that point, you can pull up the first PCB, the top PCB, and it's connected via a board-to-board PCB connector. You can pull out the XLR connector now too, actually, but I think I'll be pulling that out later. Once you remove the top PCB cable, you can now disconnect the ribbon cable for the XY stereo mic assembly. Just be careful when handling the cable, it's a bit flimsy. Yep, there we go. Pulled out the XLR assembly, and that's another board-to-board PCB connector. So we've got a few more screws here to remove the XY stereo mic housing. So once the XY housing has been removed, you can now pry open the front cover of the unit. As you can see now, I actually decided to place it back because I found the LCD screen was swinging out, and yeah, so I decided to place back the front cover in order to support the LCD screen. And yeah, anyhow, at this point you can now pull out the middle PCB, which is the one we need, and again, it's just connected via a single board-to-board connector. So as you can clearly see, we've already modified this unit before by soldering a headphone jack directly into the socket. Yikes, yeah, so we had to cut open the original socket. I mean, it worked for the time, but it wasn't the ideal fix, definitely. So as mentioned earlier, this is the pink PJ3053 component. And we all know by now it's the wrong socket. And yeah, I'm just trying to dry fit the part and I'm checking how to desolder the component. So So you can definitely skip this part. I first desoldered the 1/4" jack. And yeah, that was the easy part, actually, desoldering the jack. Now, the hard part, desoldering the actual component. Yeah, this thing is probably one of the most challenging components that I've ever desoldered in my experience. Your mileage may vary, of course, but yeah, use whatever technique in your skill set. Of course, you're going to need a quality solder sucker if you've got solder wick, manual prying and whatnot. Just be careful, of course, to not damage the PCB and the small resistors around the component. That was definitely the challenging bit. I think that went well. Let's try and pry off that component. As you can see, that didn't go so well. So yeah, I guess just a tip for you guys, if it doesn't come off easily, do not force it. You can try and desolder from the other side, of course. So yeah, I won't bore you with my frail attempts. I eventually got the PCB ready for a dry fit. And as you can see, yep, that's the incorrect component. We all know how that went down. But yeah, you know, soldering the new component back into the PCB was actually the easy part, and you do your cleanup with 90% or better isopropyl alcohol and place back the components in the reverse order. And yeah, no joy for this recorder. So, time passed, did some research, got the new component, and we're back at it. You guys know the drill by now. Desolder the old component, dry fit the new one, resolder, reassemble. Just a few notes on reassembly. For the middle PCB, just line up the board-to-board connector, apply even pressure, and you should feel the board snap into place. Align and insert the side faces first. Connect the front half of the XY stereo mic housing. Insert the XY mic capsule and attach the ribbon cable. At this point, you can reconnect the top PCB, again via the board-to-board connector, and you should hear it snap into place. Reconnect the XY stereo mic power cable and close the housing. And then reconnect the XLR assembly and its power cable. Again, don't worry about the orientation of these power cables. They only go in one way, so you shouldn't accidentally switch up the polarity on these. Don't forget which cable connector goes where, and at this point, hopefully you guys took photos during your disassembly. That would really be helpful right now. Oh yeah, don't forget the stamina switch. I tend to always forget to align this one correctly. And the last cable. So yeah, the power connector for the AA batteries. I tend not to reconnect the external speaker. That's just a preference because I don't care for it accidentally playing back on set, which has happened a few times before. I believe you can turn it off in the most recent firmware already, but I still disconnect it. And yeah, it's not the best for critical listening anyway when double checking your recording, so yeah. Alright, final stretch. Close up the back plate and there should be a satisfying click here. I chose to check first before closing it up. But yeah, just don't forget about the 5 back screws, 4 along the perimeter and 1 long screw in the middle. Oh my god, it's working. Oh yeah. That is working. You're officially back in business. Alright guys, that's it for this repair video. Again, please proceed at your own risk. I can't be held responsible for what happens to your unit. Everything I shared today is simply just what I experienced repairing my own unit. Alright? So, I hope you learned something, and I'll see you in the next one.